Hey guys, here's some reviewing for your trig part of your final review. To start off with, we're looking at some trig ratios. The tangent of an angle is equal to the opposite divided by the adjacent value. Here's our opposite, here's our adjacent. 6 over 8 or 3 over 4 would be our answer. For numero 4, cotangent, which is the reciprocal of tangent, is going to be the adjacent divided by the opposite. Based on this angle, here's our adjacent, here's our opposite. Our value would be 15 over 8. Number 6, we're looking at the cosecant of theta. And cosecant, we said, is the reciprocal of sine. We know that because they go with the wrong letter. Cosecant is going to be hypotenuse divided by opposite. So we're looking at 2 root 2 divided by 2, which is the square root of 2. Hi, Brandon. How are you? I'm well, thank you. Okay, now that we got past that interruption, we're going to continue with number 7. Everybody say hi to Brandon when they see him. Number 7 says that we have cotangent of theta is 4/3. I'm going to draw a triangle. Cotangent is adjacent over opposite. So that's 4 over 3. That means hypotenuse is going to be 5. And cosine, which is adjacent over hypotenuse, would be 4/5, which is choice D. Looking at number 10, we've got cosecant. And again, cosecant is the reciprocal of sine, so that's hypotenuse over opposite. And if I've got a hypotenuse over opposite, that's 5 over 4. Pythagorean theorem tells me my remaining side is 3. It's a 3, 4, 5 right triangle. Cotangent is the reciprocal of tangent, so it's adjacent over opposite. Adjacent over opposite is going to be 3 over 4. Anything else on this page to talk about? Oh, good. We got some angles to look at. That seems fun. So we're trying to find some values for angles. And I'm going to base this on angle B, because that's where the angle I care about is. We know the hypotenuse, we know the adjacent. So we're dealing with cosine of angle B is equal to 5 over 13. And I know in order to get that angle, I need to use arc cosine or cosine inverse. Cosine inverse of 5/13. And when we do that, we get about 67.4 degrees, which is answer choice C. Let's jump to 16. Same type of problem. We're looking at angle B, and I've got the opposite and hypotenuse going on here. So we're talking about sine of angle B is equal to 11 over 15, and we know to get the inverse, we got to do sine inverse of 11 over 15, and that's going to give me angle B, which is my theta in this case. So if we do sine inverse of 11 divided by 15, we end up getting 47.2 degrees. Next up, we got some word problems. I'm going to start with 17, then kind of skip around. So we got a flagpole. It's casting some kind of a shadow. So there's my flagpole. Shadow is going to be along the ground. Oh, look, it makes a right triangle. We have an angle of elevation in the sun of 57.4 degrees, 42-foot shadow, and we care about how tall the flagpole is. This is going to be tangent. So tangent of 57.4 is equal to x over 42. 42 times the tangent of 57.4 would be my height. And do that out and you're good to go. Now I'm going to skip a little bit. Let's talk about number 20. You're 200 yards from a river. I'm going to draw the river. Cool. This is you, and you are 200 yards. Rather than walk directly to the river, you walk 400 yards along a straight path to the river's edge. Okay, so you're not walking straight to the river, but you are walking directly to the river's edge, and it takes you 400 yards. We're going to make an assumption that this makes a right angle, just because this is a right triangle problem. Find the acute angle between the path and the river's edge. We're talking about this thing here. So we're dealing with the opposite and hypotenuse. So if sine of the angle, let's call that angle question mark, is equal to 200 over 400, that means that we're doing sine inverse of a half in order to get that value, and that happens to be a 30-degree angle. Jumping over to 22, we've got some kind of a triangle. Looks like we're labeled ABC. And A is 45, C is what we're looking for, B is 38, C is 35, and that means that I can figure out that angle A, 180 minus 35 minus 38, and I get 107. I've got an opposite pair. This is not a right triangle, so I'm going to use law of sines for this. So we're looking at, I'm going to use the upside down version because we're solving for a side, and that makes it a little bit easier. 45 over sine of 107, and that's equal to question mark over sine 35. If I multiply both sides by sine 35, we get 45 sine 35 divided by sine 107. That's what the answer would be. To be honest, if it were a free response, you get full credit at that point, times sine of 35 divided by sine of 107, and we get 26.99. Okay, I'm going to jump over to number 25 because there's a little bit more room over there. Same thing, we got triangle ABC. Measure of angle A is 27 degrees, B is going to be 26, and angle C is going to be 132. Just like I did a few minutes ago, 132 plus 27 is going to be 159. We need another 21 degrees to get angle B. And we're looking to find A. Okay, so I don't know if I do this in the non-upside down version so we can see what that extra step is. So sine 27 over A is equal to, we can use B, I guess. And B, I cannot actually read whatever. Is that 21 or a 4? I think that's a 21. So let's say sine 21 over 26. Those angles are pretty similar, so I'm going to expect my value to be pretty similar to side B. Just as kind of a prediction thing, that's a nice thing to do. I'm going to move side A over to this side, multiply by 26 on both sides, and then divide by sine of 21. And in doing so, we get 26 times sine of 27 divided by sine of 21. So 26 times sine of 27 divided by sine of 21. We get that A is equal to 32.93. That's pretty close to 26. It's a little bit larger. 27 degrees is a little bit larger than 21 degrees, so that makes sense as well. As I draw on this paper. Okay. Looking at 26. We got A, B, C. I'm already feeling law of cosines here because I see 3 different side lengths. So 21, 28, and 10. We care about angle C, so that's the one I'm going to set up as my law of cosines. So 21 squared is equal to 10 squared plus 28 squared minus 2 times 10 times 28 times cosine of C. Okay, 21 squared, I think is 441, is equal to 100. 28 squared I don't have off the top of my head, but that's going to be 784. And then 2 times 10 times 28. That's going to be 560 cosine of c. Here's where you have to be careful. We can't combine the stuff on the right side, so I'm going to subtract 100 and 784 to the other side. So that's going to be minus 100 to both sides, minus 784 to both sides, and 441 minus 100 minus 784 is going to be negative 443. That's equal to negative 560 cosine of c. Divide by negative 560. 0.791 is equal to cosine of c. We know we got to do inverse cosine of 0.791, and that's going to tell us c. So inverse cosine of that, and I get 37.7 degrees. You can expect to see one of these on your final because these are a little bit more challenging and require a little bit more nuance as far as the math that you're doing. So let's talk about another one of these. Let's look at, I don't know, 27. We got A, B, C again. Side A is 12, side C is 13, and side B is 9. I'm looking for B in this case. So I'm going to start this off with 9 squared. So 9 squared is equal to 13 squared plus 12 squared minus 2 times 13 times 12 times cosine of b. Same deal. I cannot combine this stuff with the other things on the side. So we got 81 is equal to 169 plus 144. 13 times 12 is going to be 156 times 2 is going to be 312 cosine of b. Cool. I'm going to bring these guys to the other side now. So minus 169 minus 144. I do 81 minus those. We get negative 232. So negative 232 is equal to negative 312 cosine of b. Divide by negative 312. We get 0.743 is equal to cosine of b. The inverse cosine of 0.743 is equal to b, which in this case is 41.9. It's 0.96, that's really 42-ish. But I ran out of room. Let's make some. There you go, 41.96. Convert each degree into radians and each radians into degrees. Ooh, the 6 is going to hang around, I guess. Okay. Let me erase that so it doesn't bother me anymore. So to go from degrees to radians, the shortest cut we can do is times pi over 180. If you know you want radians, the pi has to be on top. But we really know this is 2 pi over 360, and that those reduce to pi over 180. So if we got 300 pi over 180, I might notice that the 10s cancel out, and I've got 30 over 18, both of which are divisible by 6, and that's going to end up being 5 over 3 pi, and you're done. For number 33, 210 degrees, again, if you want to do 2 pi over 360, that's fine. I'll do that with this, and that's going to get me the same answer. I get 420 pi over 360. I happen to notice that both of these are divisible by 10, so those go away, and now both of those are divisible by 6. I'm left with 7 pi, and on the bottom, 6 times 6 is 36, so we get 7 pi over 6. For number 34, times pi over 180, and I notice that 165 and 180 are both divisible by 5. 5 times 36 is going to be 180. So I get let's see if I can actually do this. 36 on the bottom, and 5 times 33 is going to be 165. Those are further divisible by 3. We get 11 pi over 12, which is D. For 37, we're going to use the opposite one of these, so 180 on top, because that's degrees. I know that my pi's cancel out immediately, and that 6 and 180 are both divisible by 6. 7 times 30 is 210 degrees. Let's talk about number 35 too, I guess. We know this is times 180 over pi, and again, I'm going to use cross-canceling to make this faster for myself. My pi's cancel. 180 divided by 3, I get 60. 2 times 60 is 120. Okay, find the exact value of each trig function. These are going for some radicals instead of decimals. You might notice on your reference sheet you have 30, 60, 90, and 45, 45, 90 right triangles. We're going to make use of those. I think that it's in terms of y. I don't have this in front of me. And that would be y, 2y, and root 3y based on this. Sine of 60 based on this triangle. Opposite hypotenuse is the square root of 3y over 2y, which is the square root of 3 over 2. Sine of 30 based on the same triangle is going to be the other angle, so the opposite y, over 2y, hypotenuse, which is 1 over 2. You can follow the same type of reasoning for all of these problems. For example, cosine of 30, I'm looking at the adjacent divided by the hypotenuse, root 3y over 2y, and that turns into root 3 over 2. These are the answers we're looking for. We're not looking for the decimal approximations of these. Cool. Same thing's going to be true for 45, 45, 90. I have no idea what letter we use for this on the review, but it's probably something like n, and n root 2. So for example, cosine of 45, adjacent divided by hypotenuse, is n over n times the square root of 2, which is 1 over the square root of 2. So you're basically just using these. You will see a couple of these on your final. You have this on your reference sheet, so these should be awesome gimmies for you.